Welcome, happy learners, to another Desmos demo.
Demo. This video is on the basics of tables. To create a table, click on the Add Item icon, select Table, and then you can input values. Let's do something simple like type in a 1, hit Return, and then it propagates you down to the next cell in the X column. Hit a 2, and then Desmos will get the idea of what you're trying to do. Instead of having you type in the next value of X, it does it automatically. So I can repeatedly hit the Enter key and open up successive rows in the table. So one defect is that we have to manually open up each row versus using a list, which is covered in a different video. When do you use tables? Let's say that you have y equals mx plus b. Add sliders for all of those, and here a line is drawn for you. Change the slope, change the y-intercept. All right, so something very elementary is maybe you want to plot points. So you would figure out an x value, and then to figure out the y value, you would do mx. Well, here for x, we want to plug in the current value of x1. So we need to create the subscript and then the 1. And then notice that our m has been defined as a slider. It's -1. So we're taking -1 times the value of x1. Then we're getting these points here. If we want to actually plot points on our red line, y equals mx plus b, we need to add into our definition of our y values, mx plus b. The Desmos has this nice little magnifier, which will zoom the fit. We've plotted out 11 points in the plane. We can click on the zoom fit and get a zoomed in version of our 11 points. Nice. And Desmos will update our points if we change any slider value, and it's very convenient. All right, so something else that we can look at. Let's get rid of the line and our sliders. We can do something like 1 over x1. This would be points on the reciprocal graph, y equal 1 over x. Zoom that fit to get a better view. Good. We can also use summation notation. Type in sum, have the index begin at 1, and then for the upper limit of the index, use x1. And then those 1 over n's that we were looking at, we can sum up those 1 over n's. Click on the zoom fit and see the behavior. And at some point in your second semester calculus, you'll cover this notion here, which is a partial sum of the harmonic series. And this view is giving you the notion that the values grow and grow and grow. And the question is, do they grow at a slow enough rate that they sum to a finite value or produce an infinite value? Let's save this table, copy the link, post it in the description, and thank you for watching. Enjoy.
Like and subscribe if you find this useful.